g of x equals 1 minus cosine squared of x on the interval from minus 3 pi over 4 to 3 pi over 4. First of all, we're interested in where is the function increasing, where is it decreasing, and where are the local maxima and local minima. For this, we use the first derivative. So all of this we can figure out from the first derivative, and using the chain rule we get that that's minus 2 times cosine of x by the derivative of cosine, which is minus sine of x, and that's 2 times cosine of x times sine of x. We can figure out where this function g of x is increasing and decreasing by looking at the sign of g prime of x. We can also find the critical points and figure out which ones are local maxima and local minima using this first derivative. So first of all, we'd like to find the critical points, and that's going to be where g prime of x equals 0 in this case, because g prime of x is defined everywhere, and setting g prime of x equal to 0, we get 2 times cosine of x sine of x equals 0, and the limits of our interest here are from x equals minus 3 pi over 4 to 3 pi over 4. And this happens if either cosine of x equals 0 in this interval or sine of x equals 0. And we know that in this interval, sine of x equals 0 if x equals 0, and cosine of x equals 0 if x equals plus or minus pi over 2. So these are our critical points. And we would like to classify them to see if they are maxima, local minima, and we would also like to find the intervals where the function is increasing or decreasing. And we do this by checking the sign of g prime of x on these intervals. So we know g prime of x is equal to 2 times cosine times sine. We can check the sign of this function by picking a point in each of these subintervals and checking whether g prime of x is positive or negative. And g prime of x can only change sign at these critical points. So if we pick the point pi over 4 here, we find that g prime of pi over 4 is 2 times cosine pi over 4 times sine pi over 4, so it's 2 over 2, which is 1 which is greater than 0. So we have the sign of g prime is positive in this interval. And likewise, if we pick the point minus pi over 4 in this interval, then we get, once again, that g prime of x is equal to 2 times cosine minus pi over 4 times sine minus pi over 4, which is 2 times 1 over the square root of 2 times minus 1 over the square root of 2, which is less than 0. And now we know that the sign of g prime of x is negative on this subinterval. And likewise, if we pick a point here between pi over 2 and 3 pi over 4, let's say 2 pi over 3, we'll find that g prime of 2 pi over 3, cosine is negative here and sine is positive, so this is less than 0. So we have that g prime is negative along here, and then if we pick the point minus 2 pi over 3 here, we find that cosine is negative and sine is negative, so when we multiply them we get a positive number, so g prime minus 2 pi over 3 is greater than 0, and therefore g prime has a positive sign along here. What does this tell us about our function g, the graph of our function g? Well, we have g of x is increasing on the interval from minus 3 pi over 4 to minus pi over 2, and on the interval from 0 to pi over 2. And g of x is decreasing on the interval from minus pi over 2 to 0, and from pi over 2 to 3 pi over 4. And also we can classify the critical points at x equals plus pi over 2. We find that g prime, as we go from left to right, is changing from positive to negative. So the graph of g of x looks something like this, and we have a local maximum. That's by the first derivative test. And at x equals minus pi over 2, again we have the graph of g is changing from increasing to decreasing, so that's also a local maximum by the first derivative test. And at x equals 0, the graph of g is going from decreasing to increasing, so that's a local minimum by the first derivative test. So all of this information we've gathered from the first derivative. Now we'd like to find out where the graph of g of x is concave up or concave down, and also where the points of inflection might be, if any. And for this we're going to use the second derivative, and this is the derivative of the first derivative of the function. And using the product rule, that's 2 times cosine the derivative of sine, which is cosine squared of x, plus sine times the derivative of cosine of x, which is minus sine of x. So this is 2 times cosine squared of x minus sine squared of x. We'd like to figure out where this second derivative is positive and negative. That's going to tell us where the function is concave up and where it's concave down, and where it switches sign, and these will be the points of inflection. We're interested in this function, whether it's positive or negative, between 3 pi over 4 and minus 3 pi over 4. The points where this function might change sign are given by, in this case, where g double prime of x equals 0, because it's defined everywhere, so there aren't any points where it doesn't exist. So g double prime of x equals 0 if 2 times cosine squared of x minus sine squared of x equals 0. And this only happens when cosine squared of x minus sine squared of x equals 0. In other words, cosine squared of x equals sine squared of x. We know if we have a look at the unit circle, this can only happen at multiples of pi over 4. So on this interval from minus 3 pi over 4 to pi over 4, this happens at pi over 4 and minus pi over 4, and also at 3 pi over 4 and minus 3 pi over 4. But of course, these are the endpoints of this closed interval. We're not as interested in what's happening there as what's happening here. So we'd like to figure out the sign of G double prime on these intervals, and we have our formula for G double prime, and we can just pick a point in these intervals and figure out whether G double prime is positive or negative. And so a good point there is pi over 2, a good point here is 0, and a good point here is minus pi over 2. And so G double prime of 0 is 2 times cosine squared of 0. Sine squared of 0 is 0, so this is 2, which is greater than 0. So that tells us that G double prime is positive on this interval. And G double prime of pi over 2 is 2 times cosine squared pi over 2, which is 0, minus sine squared pi over 2, which is minus 1. So this is less than 0. And likewise, G double prime of negative pi over 2 is going to be 2 times cosine squared negative pi over 2, which is 0, minus sine squared negative pi over 2, which is minus 1. So this is also less than 0. So we have that the second derivative is negative between minus 3 pi over 4 and minus pi over 4, positive between minus pi over 4 and pi over 4, and negative between pi over 4 and 3 pi over 4. And of course, this means that the graph is concave down on this interval, concave up here and concave down here. So the graph of g of x is concave down, on the interval from minus 3 pi over 4 to minus pi over 4, and on the interval from pi over 4 to 3 pi over 4. And the graph of g of x is concave up on the interval from minus pi over 4 to pi over 4. And now G double prime switches sign at minus pi over 4 and pi over 4, so we have points of inflection at minus pi over 4 and pi over 4. And at these endpoints, the graph does not continue, so we don't count them as points of inflection. Now the actual graph of this function is shown here, and you can see what's going on. We have a local maximum at minus pi over 2 and at pi over 2, a local minimum at 0. The graph is increasing from minus 3 pi over 4 to minus pi over 2, and from 0 to pi over 2, decreasing from minus pi over 2 to 0, and pi over 2 to 3 pi over 4. And then you see these points of inflection here where it switches from being concave down to being concave up, and vice versa, and they're at minus pi over 4 and pi over 4. And we see that the graph is concave down between minus 3 pi over 4 and minus pi over 4, and between pi over 4 and 3 pi over 4. And we can also see that it's concave up between minus pi over 4 and pi over 4.